Hey everyone, welcome to the first video for programming the clamp part. This is the first part that we're going to machine for our zero set indicator. We're actually going to make 3 of these parts because there are 3 in the assembly. So let's take a look at that real quick, just so you get an idea of why I'm doing that. So here is the assembly, and you can see there's 1, 2, 3 of these clamp parts. So these 2 on the top that are highlighted in yellow, those are going to have a through hole in the center, and that's for this to go through and for this knob to go through. And then this lower clamp part is going to have threads. Alright, so this shaft here is going to have threads. You can see a little wireframe view. Not so good. Anyways, come on. Sorry, a little issue there with the control panel. Okay, so anyways, so this lower one has a tapped hole, and these 2 up here have clearance holes. Alright, so if we open the part that I send to you, the clamp, you're going to get this little pop-up. It says tapped or default, so it doesn't really matter. You can just click default. So in comes the model. And so like I said, we're going to make 3 of these, and we're going to actually make them at the same time out of 1 piece of stock. Alright, so the first thing we're going to want to do is copy this part over 2 times so we get the 3 models in the configuration that we want them. So go and click on that, transform, translate. I want to move, and the distance. Alright, so how far do I want to move it? Well, I can start by doing this from 2, and I can start from this corner to that corner. Let me zoom in. Right there. Oh, I'm sorry, copy. Now move. Alright, and then I need a little gap in there for my end mill. I'm planning to use a 1/4 inch end mill because it's a pretty small part. So I'm going to use a 1/4 inch end mill to do the profile around the part. So I'm going to want to increase that distance by 1/4 inch plus a little extra. So I will go plus 0.3, and then I want 1 more copy. So right here in the number of instances, I'm going to increase that by 1, so it's 2 instances copied, just like that. Green check. Right click, clear colors. Now I have my 3 parts. Now you might think, alright, this hole, right, they all just look like through holes, and they are, but it doesn't really matter. All the hole really does is give us our location. So depending on what we do with it is how the hole will turn out when we machine it. Okay, the next thing I'm going to do is I'll bring in the machine. I use mill 3-axis VMC. You can use default, doesn't matter. And I'm going to go to the stock setup. click on all solids. That's going to give me the overall. So if I was to click the green check, you see it puts the stock around all solids. Our stock's going to be a little bit bigger than that though. It's going to be 3/4, and we'll cut it 4.5 inches long, and it's going to be 3/8 thick. Okay. We can move it up in Z a little bit. Okay. There we go. So I made that change to 0.275. That gives us a little material on the top to face off. Alright. So the next thing I'm going to do is I'll bring in my plane, my coordinate system. I'm going to go here to the plus. I'm going to do a from solid face. Right there. That's the orientation I want. I'm going to click reselect. I'm going to snap it to this corner right here. And then I'm going to move it minus 0.075 in X and plus 0.0625 in Y. That should get me on the corner. And then Z is at the top. Top of the part, not top of the stock, just like we set up before. Check. And then highlight that, hit the equal sign to make it my current plane. Okay, and last thing I'll do before I start throwing toolpaths at it is I'm going to go into tool settings and assign tool numbers sequentially. Alright, so our first toolpath is going to be facing. So we'll face the top. So face. And if I come over here to wireframe, it'll tell me just to select OK to use the defined stock, so I don't really need to choose any geometry. I can just use the defined stock. Green check. For my tool, I'm going to use a 3/4 flat end mill. Okay, speed and feed info right here. So I'm going to go with 750 surface speed, 2,500 chip load. Plunge rate, I can bump that up. I'll just go to 20. Nice even number. Okay. So you might not get those if you use a 3/4. Let me do this. I'm going to do a right click edit tool. So I'm using a 3 flute here on the finalized properties. I'm using a 3 flute. The standard one you might have is a 4 flute. So you'll want to change that to 3 flute. So if you change that to 3 flute, then you come back in and put in the numbers for surface speed and chip load, then you should get the same speed and feed numbers as me. Okay, and then rapid retract. Alright, for cut parameters, I'm going to change the style to 1 pass because the diameter of the end mill is greater than or equal to the width of the stock. So I don't need to go zigzag or anything like that. And then here are the overlaps. So yours may look different. If they do, you want to change it to match mine. Have all this stuff kind of set in my defaults, which we'll show you how to do that later. Alright. Depth cuts I don't need. Linking parameters. So retract, feed plane, top of stock, and my depth is 0. Okay. Coolant, make sure coolant is on. Green check. There's my facing pass. Alright, now that we got it faced, we can go ahead and attack these holes. So we have 2 holes which will be clearance holes for a 1/4-20 thread, and then the third one will actually be tapped 1/4-20. So first thing I'll do is spot the holes. So drill. I'm going to select the first 2 holes. The spot's going to go a little bit deeper on those to give us our chamfer after the hole's drilled. So over here is the spot drills. I have 2 set up, one for aluminum, one for steel. So just grab your spot drill, 2500 RPM, 10 inches a minute. Drill, and I want to go for my depth. It's going to be about a 260 thousandths diameter hole, and I want about a 10 thousandths chamfer. So that gives me a diameter of about 280 thousandths. So with a 90-degree chamfer, my depth would be half of the 280, which would be minus 140. Alright, no tip comp. And coolant is on, green check. And then for my third hole, that's going to be a 1/4-20 tapped hole, which is 250. So it's going to not quite go as deep on the spot and still get a 10 thousandths chamfer. So we'll hit drill again, get that third hole. Same tool, same speed and feed, same cycle, just that now my linking is going to go minus 0.13. And coolant is on. Next, I'm going to drill this hole for the 1/4-20 thread. So consulting my drill chart tells me that a number 7 drill is the right size for 1/4-20 cut tap. So that's going to be number 7 drill, 0.201. Okay, and let's kind of crazy speed and feed. Usually go around 100 surface speed and about 5 thousandths for that drill. So I'm just going to do a straight drill. Don't need to peck or anything. It's not going very deep. Alright, let's see. So for my for my linking parameters, my depth, I'm just going to say minus 0.375. And I'll add tip comp for this one. Okay, coolant is on. Green check. Okay. Highlight those. Hide those tool paths. And then drill. And I'm going to click on this one here, copy previous point. So I'm going to do that same hole. I'm just going to run the tap through there now. So green check. And for my tool, I'm going to go select that 1/4-20 tap. Filter. I'm going to be careful here because left and right hand taps. So right hand tap, 1/4-20 right there. Green check. Speeds and feeds are kind of weird. I like to go 10 inches a minute. And it also helps you double check that your speeds and feeds are right. If you multiply the feed rate times the number of threads per inch, 20, 10 times 20 is 200, and that is your spindle speed. Okay, so for our cut parameters, go to tap, linking, go minus 0.4. Taps I usually like to retract a little bit higher, so 0.25. And no tip comp on a tap, so turn that off when it's on. Okay. Then I can go ahead and drill these other 2 holes for the clearance hole. So drill again. 1, 2. Recheck. For the tool, 260 is not, it's not a real drill size. So we can go ahead and use a letter G, which is a 261. Okay. Again, it's just clearance for a 250 thousandths 1/4 inch screw, basically. So letter G works. Go ahead. 100 surface speed, 5 thousandths chip load. Cut parameters is going to be drill, linking minus 0.375, and tip comp. And coolant is on. Oh, yeah, I gotta fix that. So I'll go back into the retract. Doesn't need to retract that high with the drill. So I'll change that back to 0.1. Check and regenerate. Better. So now we got the holes done. We have left to do are the grooves and the profiles. So first thing I'm going to do is I'm going to go around the profiles. So that's going to be a contour toolpath. Alright, and I'm going to use my solid selection tools here. So again, edges like a single edge you can link. A loop is like a full chain in wireframe. Partial loop is like a partial chain in a wireframe. So I want a full loop, and I'm going to select. Obviously, I can't select anything up here on the top because it won't give me the path to go all the way around the part. So I'm going to have to use this bottom geometry here. So there. So when I hover my mouse over the edge, it shows me that dashed rectangle that aligns with the path that I want, just like that. Okay, so I'm going to go ahead and do that for the other two parts as well. Click that, and click that. Okay, so green check. For my tool, as I said, it's going to be a 1/4 inch end mill. So filter to end mills, 1/4 inch flat end mill, green check. Again, I've already got you can see the dash AL. So all those ones with dash AL, those are ones that I specifically set up with speeds and feeds. So you can go ahead and copy those. Okay. For my cut parameters, it's going to be wear compensation, 2D contour. I'm going to go ahead and add this external corner break radius. That way I don't get the sharp corners on the part. So I'm going to go ahead and put 20 thousandths for an external corner break radius. Okay, I don't want to leave anything on the walls or the floors. Okay, my lead in, lead out information. Again, this is my sort of default stuff, so you can copy that. And then I usually don't do the midpoint. So if you do the enter exit at midpoint, then it's going to start in the middle of the part here, and you're going to get a little divot side of your part. So if you uncheck that, it's going to start at the corner. Alright, multi-passes. So I'm going to go 2 at 10 thousandths. That's basically going to give me one rough pass and a finished pass at 10 thousandths. And I usually always like to do one spring pass. That's just my default, but I mean, for this may not be necessary, but we'll leave it in there anyways. Alright, so now for the depth, we're holding this in Mighty Bite jaws. The stock is 375. The part is 1/4 inch thick, so that gives us 125 thousandths. We need 100 thousandths for the Mighty Bite to hold on to, and so that leaves us about 25 thousandths. We need a little bit to face off the top, probably about 10 thousandths, so that leaves us about 15 thousandths. So what we'll do is we'll just go to about -260. Now you notice that it came in at -250 because the geometry that we selected was the bottom of the part. So it's going to automatically put in that depth of the geometry that we selected. Alright, so 260 deep, coolant on, green check. Okay. So if we want, do a quick little verify, kind of see where we're at so far. All right. Looking good so far. So we just got to do, we got some chamfering. So first thing we'll do is we'll do these big grooves here. We're going to use a chamfer mill to do that. Those are at 90 degrees. So that's going to be a contour toolpath. And this time I want to use single edges for my selection. And I'm going to go ahead and select the bottom edge there. Okay. You can notice I went back and forth. That'll allow the tool to make a more efficient path. So for this tool, it's going to be a 1/2 inch 90-degree chamfer mill. Chamfer mills are over here, top right corner. Double click on that, and 1/2 inch 90 chamfer mill. I guess I don't have one set up for steel or for aluminum, so I'll just use the steel one and modify it. So if I do a right click, edit tool, change that. Alright, so I'm going to change it to 500 surface speed, 2,500 chip load, and 40 on the plunge, rapid retract. Kind of slowing it down a little bit on the feed rate because it's going to take a pretty good cut there in that groove. So cut parameters. So for this, for compensation type, I'm going to actually turn the compensation off, right? Because I want the center of the tool to follow that geometry that I selected. The center of the tool is going to go right down that edge that we chose. Alright, and then I'm not going to do a lead in or lead out. Actually, I will, but I'm going to take away the radius. I just want a straight line in, straight line out. Since I'm not doing wear compensation, I don't need really a lead in, an arc in. Alright, and then multi-passes, I don't need that. Let's see, linking parameters. Okay. So if I click on this depth here, I can select wherever I want the depth. So it should have already come in because that's the geometry that I chose. Again, it's a nice thing about using solid geometry instead of 2D wireframe. Alright, coolant on, check. Alright, so there's that. Now, the thing with sending the half-inch chamfer mill through there, it's fine, but it does kick up a burr on that edge or on the side here when it comes out. So over here, you know, certain sides, this is going to be a pretty good sized burr. So what I'm going to do is I'm going to take the end mill and just run it around one more time to clean that up. That way we don't have to do it by hand. So if I click on toolpath number 7, highlight that one, make sure no other toolpaths have a green check mark. Then I'm going to hold the right mouse button down and drag it down here, release the button, and select copy after. So that brings my flat end mill contour. Basically I just copied that down, and I'm going to go into the parameters and I'm just going to take out those multi-passes because I don't need the multi-pass. I just want it to go around one time just to clean up the burrs. So green check and then regenerate. And then the last thing is I'm going to send a deburring chamfer mill, a smaller one, just around the top rectangle, just to get all these little edges here and here and here. So all those little edges around the outside, that'll be sharp. So that's going to be like our deburring. Okay, so again, contour, and I'm going to select loop. And again, I'm going to check, just like before, these 3 rectangles. Okay, so it gives me the path around the outside that's going to get all those outside edges for me. For my tool, this time I'm going to select a 1/4 inch chamfer mill. So there's my speeds and feeds for the 1/4 inch chamfer mill. And then this time for the cut parameters, my compensation is going to be computer, and my contour type is going to be 2D chamfer. So this is going to allow me to specify the chamfer parameters. So I want a 10,000ths chamfer. The bottom offset, as you can see there, bottom offset creates the chamfer to move over to the side to hang off, so it'll cut because the chamfers don't cut on the bottom. So my bottom offset is going to be 0.05. My lead in, lead out, it's going to be like normal. And then for linking parameters, when you use this 2D chamfer routine, you're telling it how big of a chamfer you want. So for your depth needs to be the top, or wherever there's going to be the sharp corner, right? That's what you want. So for us, that's actually the top. That's 0, Z0. Now it says minus 0.25 here in the depth because we chose the geometry at the bottom of the part. But we had to do that because that's what gave us the path that we wanted. So I'm going to change this to 0. Alright, coolant's on, green check. Okay, so you can see that. If I do a back plot on that tool path, you see the chamfer mill going around, taking a little shot. Okay, So let's see. Let's go ahead and save it at this point. And then I'll highlight all the toolpaths and I'll do a verify. Alright, looks good. And that completes OP1.